All right, team. Yeah, going quiet at the moment, but basically just wanted to take this session at the moment. I'm going to be doing sequence and series. Just got this sent and, got to get it done, right? So basically this session, I'm just going to go through this particular task here. It is for sequence and series, and I'm just going to give a rundown of how you actually go about doing this particular task. Now, I know that people are doing like a lot of different things. Hey Thor, how you doing? And I will get to them. It's just been a bit busy over the last kind of week and a bit, but I was like, oh, should I do this as a recording or just do it as a live stream? So I was like, you know what, let's just do this as a live stream. So quick questions is when am I? Yeah, I'm good, thank you. When am I going to do the rest of them? We'll get to it. I just need to get through a few more weeks at school, and I'll start doing all the exam papers, and then after that we'll actually start doing probability. All right, so I'm going to get started with this straight away. So we're doing sequence and series. If you're not doing that standard, then don't stress too much. Go take the time off. But if you are doing it, yeah, just hang around and ask questions as we go about. All right. So looking at this particular one, we've got a ribbon that's, what is it? We've got two patterns that the ribbon's getting cut at. So we've got pattern one. So if you look at pattern one here, so this is pattern one here. So we're going to be starting with 50. And then we're going to be saying that each piece is going to be 3 centimeters shorter. So it's going to be 50, 47, 44, 41, and pretty much so on. It just keeps going, right? Pattern 2 is cut the first piece, so it's 50 centimeters long. So the first piece is going to be 50. And then each successive piece so that it's 40% shorter than the previous piece. So if you think about it like in a ratio, it's decreasing by 40%. So that means only 60% of the 50 is going to remain. So kind of putting it like this, 0.6 times 50. I'm just going to work it out in the calculator. What do we got? 0.6 times 50. So that's going to be 30. And then it's going to reduce by another 0.6. Sorry, reduce by 0.4. So it's going to be 18. And then 10.8. and so on. So pretty much what we're trying to establish here is that pattern one is, by the way, I haven't actually done this standard in like, when was the last time I did it? I think I did it in 2015. That's a long time, literally 10 years ago I did this standard. I've not touched it since then. So if I do make mistakes, feel free to yell out. It's very possible. So pattern one is going to be arithmetic progression patterns. Geometric is pattern two. So that's what we are looking at. Hey Aniket, how are you going? Welcome. All right, so what do we got? We've got, ideally Rihanna would like 20 pieces of different lengths that would use exactly 4 meters of ribbon. So all together, Rihanna's got 4 meters of ribbon. Okay, so that's what we know. So task one, the first part is like, so I'm looking at the first, I'm gonna call this part A, B, C, and D. So part A is looking at which pattern 1, pattern 2 results in greater number of pieces being cut from 4 meters length. And then part B is find the minimum length of the pieces for both patterns. All right, so let's just look at the first one, all right? So I am going to be looking at pattern 1 first. So when we look at pattern 1, pattern 1 starts off from 50 and it goes to 47, 44, and 41. Now, what's happening to these numbers? These numbers are actually reducing by 3. So basically, if you think of an arithmetic progression, like, I always get that wrong. Is it progression or sequence? I'm sure somebody can correct me. So the A value is going to be 50 because that is what the first number is. And then D, which happens to be the difference, in this case, is going to be -3 because it's reducing by 3, those numbers. All right. Now, once we have that, we want to know, if you look at part A of the question, it says, our usual visitors have decided to grace us with your presence. So the first part of this question is that we want to know if you keep cutting these pieces from like 50, 47, 44, and so on, when you have 4 meters length of ribbon, we want to know which pattern actually gives us more pieces. So we're looking at the total number, like we want to know which number is going to add up to 400. So if you think about it, so when we cut 2 pieces, it's going to be 97. When we cut 3 pieces, it's going to be 97 plus 44, which is 141. And you know, you don't really want to do that manually, right? Like you want to be able to show a formula, and I think the formula will we use the sum of arithmetic sequence formula, I think it is, where the total sum is equal to n over 2, and then in bracket we're going to get 2a plus n minus 1d. Now what we are trying to figure out is for what value of n is the total going to equal 400. Now I say 400 because 4 meters is actually 400, is it 4 meters is 400 centimeters? Yeah, it is. Yeah, there we go. So because 4 meters, I'm just going to write that down here. 4 meters is equal to 400 centimeters. I mean, alternatively, you can actually use 4 as well, but then your A value would become 0.5, and then your D value would become negative 0.03. So we're going to go with 4 because 400, that's easy. So S is equal to 400. And then N, we don't know what N is, so we're going to go N over 2. Bracket 2 times A is equal to 50. Plus N, we don't know what N is, N minus 1 times D, which happens to be negative 3. Now once we get this, what we need to do is we need to figure out what the N values are. Now Joe, it hasn't changed, it's just sequence and series, just working through a question. So what I'm going to do is I'm going to cross multiply the 2 first. So when I cross multiply the 2, I will get 2 multiplied by 400 equals, inside the bracket I've got 50 times 2, which is 100, plus, maybe not plus, now let's go actually get rid of the plus, because what I've got is negative 3 times n, which is going to equal negative 3n. Then I've got negative 3 times negative 1, which equals to plus 1. Just checking my working to see if I'm actually on the right track or not. Hey, Tamani. All right, so what we've got is we've got 800 is equal to, double checking it. I forgot the n over 2. No, not n over 2, just the n. So I'm going to get 800 is equal to negative 3n. What am I missing? I feel like I'm missing something. Negative 3 plus 3. God, I'm making lots of mistakes today. So that's why it's a good idea to actually have answers ready. Sorry, that should have been a 3. So I've got negative 3n. I got 97. Why am I getting 97? Where am I making this mistake, dude? 100 plus 3 is 103. It is 103n. Okay, yeah, 103n. Just double checking that. Cool, so I've got 800 is equal to negative 3n squared plus 103n. Just want to check I've got everything here. Negative 3n squared plus 103n. Yep, got that. Cool, so the way I got that was, remember, n times negative 3n is equal to negative 3n squared, and then n times 103 is 103n. All right, now we're going to rearrange this so that we get a nice quadratic equation. So bringing all the right-hand side into left-hand side, or you could do it the other way. You can do that way as well, Annika. It doesn't really matter. So we're going to go 0 is equal to minus 3n squared plus 103n minus 800. Now, at this point, you can actually use your calculator to try and figure out what the n values are. So we're going to go n is equal to, but to do that, we're going to use the graphics calculator. We're going to go into equation, and go into polynomial, which is f2 degree 2, and we're going to punch in these numbers, which is -3, then 103, and then -800. Now when we get this, we actually get n is equal to 22.46, and we're also getting 11.872. So this is where, you know, you've actually got two values here, and you can kind of see it doesn't, like, if you think about it, right, like eventually the pattern here, it's actually gonna become 0 and so on, right, eventually, right? So what if you look at like 22.46, right, we can try it out. We can actually put Tn. So I want to actually figure out T of 11, and I also want to do T of 22. Now the reason why I want to do less, because obviously when I do the 11th term, there's going to be some piece that's going to be left over, so that's why I'm only going to go with 11. So when I do T11, T11 isn't that a plus n minus 1d? I'm sure it is. Could be wrong, I can't remember. So if we do a plus n minus 1d, for T11, a value is going to be 50 plus 11 minus 1 times -3, and that's going to give me 50 plus 10 times -3 is -30. That's going to give me 20. Now that's shortest length is 20. Okay, that kind of seems to make sense. But if I do T22, let's see what happens. I'm going to get a plus n minus 1d. I'm going to get 50 plus 22 minus 1 times -3. That's going to give me 50 plus 21 times -3. Now, when I do this, if I do 50, I'm actually going to end up with a negative number. 50 plus 21 times -3, that's going to give me -13. So basically what this is telling me is that, you know, as I'm cutting these pieces, there comes a point when it'll become 0. And basically this is saying that the 22nd piece, the length of the 22nd piece is going to be -13. And that doesn't make sense. So in this case, we actually have to say that n cannot be 22. So n can't be 22 because Tn equals to negative. Therefore, n has to be 11.87. But we probably are going to go with the rounded up, not rounded up, rounded down value of 11. Okay, so once we have that, we can actually figure out. So if you go back to the question, it says we also need to find the minimum length of the pieces for both patterns. So that's part B there. If you look at it, part B is asking for the minimum length. So we need to find the total of the 11 pieces and then go 400 minus that to give us what's actually oh no, I think that I'm actually doing part C as well, right? Yeah, actually I'm going to do part C as well. Like, let's just do part B first, which is minimum length for pieces for both pattern. So I would like to know what the sum of when we actually do 11 of them is. Okay, so we know 20 centimeters is the shortest piece. So that's the shortest piece. Now we want to know how much of these pieces are actually used up. So we're going to go 11 over 2, bracket 2 times 50, plus 11 minus 1 times -3. So when I do this, I'm going to get 5.5, bracket 100, 10 times -3 is equal to 10 times -3 minus 30, so that's going to be 70. So we have 70 times 5.5. So that's basically giving me 385 centimeters. So the amount that's actually discarded is 400. Take away 385 equals 15 centimeters. That's actually going to be discarded. Now, if I go back to the question, that I'm actually done part A, B, and C there. Because part A was looking at the number of pieces that's getting cut. So for pattern 1, I found that it was 11 pieces. The minimum length of pieces that's for both patterns, I found that as 385. And the least ribbon is 15 well, not the least, the whatever is left over is 15 for pattern 1. Now I need to do the process for pattern 2. So pretty much the same thing, except for pattern 2, it's a geometric progression, right? So, or sequence. I always get confused. Anyway, let's go with pattern 2 now. By the way, I might just pause. If there's anybody watching and have any questions, feel free to ask. Otherwise, I'll give it 30 seconds and then continue. All right, let's go to pattern 2 then. So with pattern 2, we started with 50, and then the ratio that it was decreasing by is like 40%. So the ratio is going to be 0.6. Now, the problem with pattern 2 is that we don't know how many pieces are going to get cut. So we have to assume that it's just going to keep getting chopped by little. So really, we want to know what would happen if we do sum of infinity. MG, funny story. I was actually looking at Cambridge papers all of last night, thinking about doing a couple of them, and I am not going to lie. I loved some of the questions there, because I think it made me think like differently, and I think I'm going to do some Cambridge papers. Are you doing Cambridge at the moment? Hey, Minty. All right, so we're going to do sum of infinity in this case. So when we do sum of infinity, we have a divided by 1 minus r. So we're going to get 50 divided by 1 minus 0.6. So that's pretty much 50 divided by 0.4. Now, here's the funny thing, right? 125 centimeters. Now, what this means is that when we do sum of infinity, like, we are reducing that ribbon by 40% every single time. And as we reduce it, that it just keeps getting smaller and smaller, and that's why we have to use sum of infinity. So when we actually do that, what happens is, with this particular ratio, we are only using 125 25 centimeters. All right. So what that means is that you can never say the end of the ribbon can never be reached. So we can kind of say end of ribbon can never be reached, because it's going to be really, really small, and it's getting close. I might say something like getting close to 0, but not 0. So basically, so in other words, it's like the amount of ribbon that gets discarded is going to be 400, take away 125. So 275 centimeters of ribbon that's going to be discarded. So if we go back to our question, what we did was, like, with the greatest number of pieces being cut, well, we can actually say pattern 2 is going to have the most greater number of pieces, because you can literally cut infinity ribbon pieces, right? And so the minimum length, but if you do the total of that is going to be 125. So what you're ending up doing is that you're actually wasting 275. So you probably need to write a little statement that says, with all of those things, pattern 2 is going to waste more material. It's going to waste 275 compared to 15 by pattern 1. In terms of number of pieces, pattern 2 has infinite number of pieces. Pattern 1, you can only go up to 11 pieces. Right, so that is pretty much part A, B, and C. I think we've done. And now we're just going to take a moment, have a look at the question D, which is to compare the two different types of sequences. And then what I'll do is I'll actually go through the question for that. MG, yeah, like, look, I've been meaning to ask, like, if I was to do I was looking at the numbers, right? Is it 0580 and 0606 for Cambridge? Which one would you like me to work on, MG, if I was to do a Cambridge paper? And which level would you like me to work on? Let me know in the chat. I'm just going to keep carrying on to this question. All right. So for the second part of this question, what's it asking? Compare two different types of ribbon. So gets exact 20 pieces and uses exactly 4 meters of ribbon. Discuss any choices you make. No problem, Minty. It's a pleasure and good luck. Stay subscribed and switch off all notifications. I'm just joking, man. I'm just joking. All right, so we're gonna go through the second part of this question. All right, so basically what they're saying is like they want exactly 20 pieces and they want 400 centimeters to be used. 0606 is such a good paper. I'm not gonna lie. I spent about an hour yesterday looking through 0606 from I think it was the March paper 11. Man, some beautiful questions, and I reckon if people actually do that, I think they'll yeah, I'm not gonna lie, there's some really good questions there. All right, so we've got 20 pieces and exactly, what is it? We're gonna do 4 meters of the ribbon, right? So there is a couple of ways of looking at it, right? So firstly, I'm gonna look at an arithmetic one. So that means everything is kind of like going through. Appreciate it, Minties. So what we've got is we've got the total, the S of n equals to 400. So that's the total, that's equal to 400. We know that we need 20 pieces. So 20 pieces should equal to 400. So if we do it as pattern 1, which is like the arithmetic one, we're going to go S of 20 equals 20 over 2, 2 times A, plus n minus 1 D, and that's pretty much it. Sorry, n is 20. I'm just going to put that here. But we don't know what your A value is, nor do we know what the D value is. So here's what we're going to do. We got S of 20 equals 400. So 400 is equal to 10 brackets 2 times A plus 19D. We're going to get rid of the 10 to the other side. So we're going to get 400 divided by 10 equals 2A plus 19D. So we've got 40 equals 2A plus 19D. Now here's where I was like trying to understand how this works, right? Like, because basically we want to substitute some values here so that this equation is actually going to work out. Now, and I was thinking about this. It's like, well, how do you actually do this, right? And so I was like, well, let's just do trial and error, because trial and error is always like fun, right? What if I say that D is going to be decreasing by 2, for example, just hypothetically. If D equals to -2, let's just say -2. Oh, actually, look, I don't think it matters whether we start with negative or positive, because you could start with a small piece and then it keeps getting bigger, because in this case, we're not, like when it's arithmetic, you can actually start from the small number and go to the big number, or you can start from the big number and then go to the smallest size of the ribbon. I'm going to do this slightly different. I'm going to start with where I'm going to put A as 1, like just hypothetically, right? If I say if A is equal to 1, then I'm going to get 40 is equal to 2 plus 19 times D, because 2 times A is 1, so it's 2 times 1. So what I've got here is 40 take away 2 equals 19D, and then D is equal to 38 divided by 19, and I'm going to get D is equal to 2. So if A is equal to 1, then D is equal to 2, because depending on how you cut the piece, right? Because I don't think anywhere it says that I don't think we have any information about that D has to be a particular value. All it's saying is they want 2 different types of sequences so that she gets 20 pieces. So if I actually have A as 1, then my D is going to be 2. Now what happens if I have A as 5? Hypothetically, right? Maybe not 5. Let's actually try, now let's just try 5. Let's just see what happens. If I put A equals to 5, then I'm going to get 40 equals 2 times A plus 19D. So I'm going to get 40 is equal to 2 times 5 plus 19D. I got 40 is equal to 10 plus 19D. And then 40 take away 10 equals 19D. I've got 30 equals 19D. And then D is equal to 30 divided by 19. Now, while there's nothing wrong with this, but what's going to happen is, like, when you get an ugly looking number like this, when I say ugly, it's like, yeah, 1.57, whatever. You know, it's kind of like, it will still work. Like if you were to do the sum of 20 and try and work it out with this A equals to 5 and D is 30 minus 30 over 19, it'll still equal to 400. So you're just kind of showing what the different varieties are. Let's actually try it out. I just want to put that in the calculator quickly to see. So I got 20 over 2, which is 10. So I'm going to do 10 times 2A, which is 2 times 5, plus, what do I got? 20 minus, so 19 times D. So 19 times 30 over 19. Hopefully I get 400. Yeah, so you get 400. So really, because you're cutting it up in, you can start with anything. And if you start with a big A, your D is going to get smaller because you've only got 400 centimeters to work with. But if you start with a small A, then obviously your D is going to be much bigger. So that's just how this particular one works. So what you could do is you could actually say something like, I'll ask you longest piece. Compare 2 different, well, they don't really talk about anything about longest piece, but you could actually say that anyway if you want to. I don't think it would matter, because in the first situation when A is equal to 1, if you try to work out T20, 1 plus n minus 1D, you're going to get 1 plus 19 times 2, which is equal to 39 centimeters. So you can say that the longest piece is 39 centimeters. And likewise in this one, if we were to do T20, you're going to get 5 plus, I'm just going to shortcut, guys, 19 times 30 over 19. That's going to give me 35. Yeah, so it's going to give me 35 as the longest piece. So it's just something to be aware of, that you can actually give them multiple solutions in this case. Now, this is just one arithmetic one. What about, let's look at geometrical one. Like if I was to do that, what's going to happen? So if I was to use a geometric pattern, then remember that S of 20 is still 400. But I've actually got the 400 equals A times 1 minus r to the power of n divided by 1 minus r. Now what I've got here is, I don't actually have the A value or the R value. So what I'm going to do is I'm going to write this down. A 1 minus r to the power of, I think, n, so that's going to be 20, divided by 1 minus r. Now, just like how I did in the previous question where I kind of substituted A is equal to some number and then figured out what R, in this one, I would strongly recommend you not to not to substitute A and then figure out R, because that's going to be like super crazy. I'd actually suggest you to do like put R as a particular value and then figure out what the A value is. So in this case, let's say if R is equal to 0.9, then we're going to get 400 equals A 1 minus 0.9 to the power of 20 divided by 1 minus 0.9. So I'm going to actually do this in the calculator. So I'm going to get 400 equals A times, of course it is Dahlia, of course. We're going to go 1 minus 0.9. Now you might be wondering, why did I go with 0.9? Well, it's just 10% decrease. I wanted to do 10% decrease just to figure out what's actually happening. So 0.9 to the power of 20. And then that's, oh, no, I don't want that. One minus 0.9. So when I do this, I actually get something is not right. Let me just check if I've done the working right here. 1 minus 0.9, 0.1. Am I missing a number? Sorry, just checking this here. So I've got 8.78, and then A is equal to 400 divided by 8.78. So if I go 400 divided by answer, I get A as, no, I think I'm happy with that, 45.53. Am I? One minus 0.9 to the power of 20. Let's just check it out. If I do that, if I go 45 is A, so 45.536 multiplied by 1 minus 0.9 to the power of 20. And then divided by 0.1. No, it does work out. Sorry. No, it does work out. Cool. So that means A value in this case is going to be 45.53. And then the next thing is if R value is that. All right. So that basically means that if she starts with 45.53 and she reduces it by 10% every single time, after 20 pieces, the total would actually equal to 400. And again, if you'd like, you could actually try it with a different R. So for example, I might just, and I think this is the thing with internals, folks, like just, there's never a kind of like a set thing. I always like to do 2 or 3 just to kind of show that I do know what I'm doing here. So here I'm going to go 400 equals A, 1 minus 0.8 to the power of 20 divided by 1 minus 0.8. So I'm going to get, let's just do this in the calculator. So we're going to get 1 minus 0.8 to the power of 20, close bracket, and divided by 0.2, because 1 minus 0.8 is 0.2. So I'm going to get 4.94, and then 400 divided by answer. So this is going to give me an A value is 400 divided by 4.94. So this is going to be A is equal to 80.93. So a second situation is if you start with 80.93 and you reduce it by 20%, after 20 cuts, the total will actually add up to 400. So basically what I've done here is for that part, I've actually given 2 arithmetic and then 2 geometric where the situations could be different. All right, and don't forget to actually explain it in words, guys. I'm just being lazy here. But I would actually write a sentence saying that if A is 45.53 and it reduces by 10%, then the sum of 20 pieces would equal 400. Likewise, if A is 80.93, then the ratio reduces by 20%. And also, after 20 cuts, it's going to equal 400 pieces. Okay, so that's pretty much part D done there that I said. Now, finally, what we have is this part here. So basically, it's kind of said that they want a general formula for the total length of all ribbons if the first ribbon cut is X meters and the longest ribbon is Y meters. So we're going to go here. So the first ribbon is X, and the longest ribbon is Y. Now, let me just grab this. Okay, so in this case, the first one I'm going to do is the arithmetic one, right? So A is equal to 1. D is, I got no idea what D is, but I do know the final value Tn is going to be Y. All right, that's the last piece. The longest piece is Y, so that's going to be Tn there. So when I look at arithmetic, I'm going to get Tn is equal to A plus n minus 1d. So Tn, which is the final piece, that's the longest piece, that's Y. So Y equals, A is the first piece, which is X, and then I'm going to get plus n minus 1d. Now, here's the thing, right? The question actually said leave X and Y in your answer. Now, problem is I've got X, Y, I've got n and d. But it's also said, if you go back to the actual question, it says they want a general formula for the total lengths. That means we want to be doing something with the sum. So if we take the sum equation, sum of a arithmetic sequence is like n over 2, 2a plus n minus 1d. Now, what do we have? We've got X. There's no way to put Y in there, but they want the answer in X and Y. So if you were to go back and have a look at that first equation, you should see that there's an n minus 1d here. There's also an n minus 1d here. So what you can then do is you can actually rewrite this as y minus x equals n minus 1d. Because now what I'm going to do is I'm going to say sum of n is n over 2. A was just the x value, so that's 2x, plus n minus 1d is equal to y minus x. Because remember, this part n minus 1d is equal to y minus x, so I can replace that straight away. So now when I do this, Sn is going to be n over 2. 2x minus x is just x, and so that's going to be x plus y. So this happens if this is in a arithmetic progression, right? Now what about a geometric one? Keeping the same kind of formula here, like, so your first a, so a is still x, Tn is still y, but we actually don't know what the R value is, what the ratio is. So we're going to do Tn, AR, n minus 1. Tn is, well, we don't know what the nth, which nth value it is, right? So we're going to, that's the longest piece. So we're going to say that Tn is equal to y, A is equal to x, and then we're going to get R times n minus 1. Now, when you look at the sum of geometric progression, you're going to get 1 minus r to the power of n divided by 1 minus r. Somehow we need to, so that's not x, that's a. We need to get rid of this rn somehow. And so the way we're going to do that is we're going to work on this side here. So we're going to have y is equal to x. Now rn minus 1 is the same thing as saying rn divided by r to the power of 1. Because remember, when you have powers that are getting subtracted by each other, we can actually rewrite this as a fraction. This is one of the things that we did in level 1 algebra. So that's all we're doing here. Now r to the power of 1, that is just r. I'm going to cross multiply this, which means I'm going to get yr equals xrn. Bear with me. So that's the first thing. Now I'm going to go back to that second equation, and I've got S of n, A is equal to x 1 minus r to the power of n divided by 1 minus r. Now I need to figure out how I can bring y in here. The thing that I want you to have a look at is that here you've got xrn. You also have x and r in here. So what you could do is you could expand the brackets. So you could do this times this and this and this. And what you're going to end up with is x minus xrn divided by 1 minus r. Then what we can do is we can separate it. We can actually say x 1 minus r minus xrn divided by 1 minus r. Now because xrn is equal to yr, we can actually say that Sn equals x over 1 minus r minus, now the xrn is equal to yr, so we're going to go yr divided by 1 minus r. Now, unfortunately, I don't think you can actually do anything further than this, but what we have done is we've actually come up with a generalized equation, generalized formula for this. So pretty much it is, it's a long question, but I feel like these, this is the first time I've done this sequence and series paper in like 10 years. So it's a good question. It's a very good question. But I think, yeah, there's just, I was confused with the wording at the beginning, but I think after playing around with it, I got a teacher to check it out. So, and they were happy with it, so that's good. 10 years, not too bad. But yeah, so guys, that's pretty much it for this little session here, cutting the ribbon practice 1 for sequence and series. If you do have any other tasks that you want me to go through, feel free to flick it to me, something similar to this. But yeah, answers definitely helps, because I don't want to go down a rabbit hole and then, just figuring out like stupid mistakes that I make all the time. Which I'm not going to shy away from. So yeah, but apart from that, that's pretty much it for this little session. I'm going to hang out for a few minutes just to have a chat, and then we'll call it for the night. Oh, by the way, if you're still hanging around, I didn't realize this, but YouTube actually hit 60K. So you know what that means. We got to do a t-shirt giveaway, right? So keep an eye out in the socials for the next couple of days, and I will be doing a 60K t-shirt giveaway. But yeah, how's everyone doing apart from that? Fluida, it's difficult for me to retain the knowledge that I've learned after the exam. Well, if I can be honest, Fluida, I can't remember what I did after my university exam. You forget about those things. I think, it's more about remembering enough to survive the exam. And then after that, it's pretty much good to go. Apart from that, how's everyone doing? Day 2 of the camp. No. Emails. Where are you at, Fluida? Like, are you in year 11, 12, 13? Math doubt year 12. Cross multiply, my friend. Wonder if this person's actually on YouTube. They just sent me a question. Nora, are you actually here in the chat? Fluida, I think year 12, my suggestion is go through the 15-hour playlist, because that definitely helps you retain things. And I would almost say do it first now, even if your teachers are not teaching it, because what happens is that when you learn it through my stuff, and then when your teachers actually teach it during class, it solidifies the learning. And then at the end, when you come to like the exam time, it definitely becomes a lot more easier. Didn't realize all of my stuff is actually moved. That's too high. I rearranged my computer, so I guess Nora is not here. I'm gonna have to do this question later. All right, folks, if there's nothing else, keep an eye on these, what do you call it, the socials, and I will let you know. Oh, do you have any graphing videos? I'm currently doing it. Fluida, I think I did like a very like random session on it. No, wrong channel. So if you go in the channel and you just type in graph, no, it's all level 1, isn't it? No, it's not gonna work. Where did I put it? Yeah, I've only got like 5 videos there in level 2, NCEA level 2. I need to update it. So what do you guys want to do? I mean, like, just let me know what you guys want to learn, and then I'm happy to kind of maybe spend a session just going through it. I mean, if you have a question, it would be amazing, because it's always fun to do it as a question. So if not, I'm happy to run like just a quick crash course on what are all the things. And again, it's been such a long time since I did graphs. I remember the graphs, but I don't remember, like, you know, when they talk about like achieved merit stuff. But definitely they do generalization and graphs. Networks? Nah. Never did it, networks, never did it. Maybe keep putting things off. No, I don't think I'll like, I know it's supposed to be fairly straightforward, but I always get confused with the nodes. Those, like, the ones like where the 2 lines come across, and I'm just like, it's too much work. But look, anyway guys, look, I gotta get going. I had a full day of parent-teacher meeting, and I've got another full day of parent-teacher meeting. Yeah, as you can tell, voice is croaking, probably gonna crash soon. But yeah, thank you for joining today, and hopefully the folks that are doing sequence and series, hopefully you find it useful. All right, till the next time, take care, keep an eye on the socials. That 60k t-shirt giveaway is coming. All right, thanks Fluida, I'll catch you later.